Hello guys, welcome to NetTechies. Today's topic is BGP Confederation. So in order to understand BGP Confederation, make sure you know what's a split horizon rule in a BGP. So what split horizon rule is in a BGP? I'll just do the quick recap. Let's say we do have a router R2 and we have a router R3 and we didn't have this link between these. So let's say, let me change it to the pen. Let's say R2 send a route and the route goes to R3. But the R3, since R2 is iBGP peer, it will not send route to R6. Okay, it will not send route to R5. Okay, because these are the iBGP peers. So to solve that problem, what we could do is we will need to have a full mesh BGP peering with all the routers. So we can do like this, where R2 is connected to this, and R3 is connected to this. Now we already have 1, 2, 3, 4, 5, 6 links, 6 BGP peerings. And imagine now you're an ISP and you have, like, say, 50 routers. You will have to have multiple BGP peerings to solve these split horizon problem. So in order to solve the problem, what we could do is we can take a one area. For example, this topology on the right hand side is similar to what we have on the left, but except I have IP addresses configured. So we could divide this entire AS30, this entire autonomous system with the red pen, into the smaller autonomous systems. So here we can have autonomous systems 65001, okay, where we have R2 and R3, and then we can have 65002 where R5 and R6 are part of the same autonomous system. But ISP10, it doesn't know what's going on behind the scenes. It just know that we are AS number 30. Okay. Same goes for ISP 100. It doesn't know that we are operating with these autonomous system. For all external BGP peers, we are just AS number 30. Okay. But we as ISP, we are managing everything under the hood. We are managing the configuration. Uh, Whatever we do, it's local to us. External eBGP peerings, they don't know what's going on. So now, instead of having these links like 1, 2, 3, 4, 5, 6, 7 links, 7 BGP peerings, we only have like single connection to each router. In the real life, you might have more connection for redundancy, but I just wanted to make a simple diagram for you to understand. So now whenever there's a new route that's, let's say, sent from ISP10, we are eBGP peer and we have a iBGP peering. So obviously we will be sharing the route that we learned from ISP10 with with the router 3. And router 3 will now have a eBGP peering, even though they are both in AS30. But to R3 it's a different AS, even though we are under AS30, all the routers, but R3 will not stop the routing advertisement. It will send the routing to R6 because we have a eBGP peering here. Okay, and same thing here. Now iBGP, we have a full mesh. R6 and R5 are neighbors. They will understand the route, and then the route will propagate to here, and vice versa. If you learn something from here, they will share because they are iBGP peer, and then this will happen. Now we don't need a lot of iBGP peerings. The confederation will solve the issue for us. This is enough for the topology. These are again, just the bullet points. It will reduce the iBGP mesh complexity, as we saw, that we don't need to have a lot of links, as you can see on the left hand side diagram. We don't need something like this, okay, if we have the BGP confederation. And then also improve the scalability. We can grow big and big. We can have 1, 2, 3 multiple routers. We can divide them into their own sub AS number and connect them with the eBGP confederation peering. Okay. So yeah, you can maintain a single public AS. So let's say if there is a router, and that router, it's connecting to your big ISP, let's say. They don't know what's going on under your hood. So yeah, you can keep growing. You can add more routers here, divide it to another sub AS, have a link, and that way you can make your efficient routing policies grow bigger without having complex configuration and more BGP peering requirements. So next section we'll be doing the labs. Okay, so now we will be starting the lab. So the first step to do in the lab is we will be configuring the OSPF on our R2, R3, R6, and R5. So imagine we're AS30 in this case, and we want to have our IGP protocol running. So we do have an end-to-end reachability. Now you might ask, we do have already a BGP routing protocol. Why do we even need iBGP protocol such as OSPF or EIGRP? Shouldn't we just use BGP? So the proper use of BGP, the main thing it's good at is routing between two different autonomous systems. Let's say AS50, AS30, AS10, AS100. But now we are the ISP and we have control over R5 and R6. We'll be using OSPF in this case because OSPF is widely supported on all the devices. It's not like EIGRP where you need to have a Cisco device to run it. We could be also using ISIS. A lot of service providers they use ISIS. So in order to get started, what I'll do is, as you can see on R2 and R3 link, we are using 10 network, and R3 and R6 are using 10 network. All the internal links we have, they are using 10 network. So what I can do is I can go to, let's say, R2. Okay, clear up some space. Country. I'll say router OSPF1. I'll say network 10.0.0.0, 0.0.0.255, area 0. Okay, so what this command will do is it will try to find all the interfaces that has a 10.00 range IP address and put them into area 0. It will activate OSPF on only 10 network. So if I go to R3, if I do conft and do the copy paste of same command, oh sorry, router OSPF1, this, and so now on router 3 you see we have 172.16.50.0 network, but since we put 10.00 network in the OSPF command, it will ignore the 172 network and enable the OSPF on this. Let's go to the R5. Let's do the same thing. Contree router OSPF 1. Okay, area 0 and write it. Conf same thing. Router OSPF 1 network this area 0. Okay, and now let's do this. Okay, so we have a full adjacency, and on the left side you can see I have loopback address on R2, R3, R5, and R6. So from R2 perspective, let's ping 5.5.5.5 source loopback 0. Let's give it some time. I have corrected the IP addresses on the router 5. So if I do show IP route, I can ping 2222, which is loopback of router 2. Let's try that quickly. Source loopback 0. Okay, so the ping is working. So at this point, we do have a OSPF working in the autonomous system AS30. We do not have any BGP configuration yet, and we'll be doing that just in a moment. Okay, this is the section where we do the BGP configuration. In the past, we've done OSPF configuration on R2, R3, R6, and R5. So they can reach on each of those loopback addresses that I have given on the diagram. So in this case, I have already configured ISP10 to save some time. I'll just show you show run config section BGP. Okay, so what we have is we are trying to advertise 203 IP address. That's a loopback on ISP10 router, and we have configured the neighbor 172.16.10.1 remote AS30, which is R2. So now let's go to R2. So you see ISP10, it doesn't know about the BGP confederation. For it, just it's a simple BGP neighbor. So now let's move to router 2. Okay, I'll do conf t. Okay, router BGP. See, we are AS number 30, but our sub AS number is 65,001. So I'll just say 65,001. Okay, and now I'll say BGP confederation identifier. This is the AS number 30 that will be showing to ISP10, but R3 will just see us as a 65001. So I'll just say our identifier number is 10, which is the actual AS number of our ISP. And I'll say we are peering with the confederation. We will be peering with the uh, 65002. Even though what I've done is I do not have any link between R2 and R5, but I supposed to have it, but I'll just skip it for now. So I'll say BGP confederation peers are 65002, which will be IP of the AS number, sub AS number of R5 and R6. But since I don't have any link between R2 and R5, this is useless. It's my bad actually. I supposed to have the link, but I forgot it. Can't do anything. So let's define the neighbor 162.16.10.2, and the remote AS is 10, which is ISP10. And then the next neighbor we have is 10.0002, and then remote AS we'll be seeing it as 65001. Okay, notice we are peer with the ISP10 now. Okay, and that's it. I'll just save the configuration. I'll just show you what we have done. Show running configuration section BGP. So we say the BGP confederation identifier is 30. That means to every other router that's not part of our AS number, they will see us as a AS number 30. But internally we are 65,001, which is sub AS number. And then we're telling it that we'll be peering with the 65,002 peers. And these are just the, IPs. So yeah, that's it for R2. Let's move on to R3. BGP confederation peers are in 65002. When we peer with the R6, we're telling R3 that your peer, the sub AS number peering number is 65002. Okay, and then now specify neighbor 10.0001. Remote AS is 65001. Okay, neighbor 10.0.0.6. Remote AS will be 65,002. Okay, and then I'll exit out of it and I'll show you the configuration. Show ring configuration section BGP. So this is the configuration on the R3. So we're telling that we are actually part of AS number 30, but we are running as a 65,001, and you are peering with 65,002, which is R6 and R5. So even if I run one more wire from R3 to R5, I'll be able to peer with it because I have the confederation. Okay. So now let's move on to the router 5. So router 5, I'll say no. Let's go to R6 first because that's the next one in topology. This is the confusing part for most people, including myself, so make sure you remember this. Although I think this will be only in the exam, you will not see the confederation unless you get a chance to work with a very big ISP. BGP confederation identifier, okay, so we told R6 that we are actually part of AS30 and BGP confederation peers, and your peers are using AS65001, okay. And then now we'll go with the neighbor statement. So I'll say neighbor is 10.00.5. and the remote AS is 65001. Okay, so 65001, its AS number is 65001, not 65002, so that makes up our eBGP. But if it was so let's say now I go with the neighbor 10.00.10 and remote AS is 65002. Now R6 knows that okay, this is iBGP peering, okay, based on the AS number we put here, and this was the eBGP peering because this is not same as our peering. Okay, I'm not using any network statements now. It's just the pure peering we are trying to achieve. And now let's go to R5. Also conti router BGP 65002. Okay, you see ISP handle doesn't know that we are 65002. It assumed that we are AS number 30. So I'll say BGP Confederation identifier 30. BGP Confederation peers are 65001. It doesn't matter, but I'm just using it. We don't have any link between R2 and R5, but I'm just putting it to make it consistent. And now I'll just say neighbor is 10.009. Remote AS is same as ours, 65002. So now R5 knows that okay, I'm doing iBGP peering with the R6. And now neighbor 172.16.100.2 remote AS is 100 and right. Okay, so now we have to configure ISP 50 and ISP 100. So let's go to ISP 50. Okay, and now say I want to advertise my network 198.51.100.100.50 and mask will be 255.255.255.255, and I think that's it. Show IP BGP summary idle. Can I ping this interface? Okay, I can ping it. But did I specify R3s? No. So let's go to R3 quickly and we'll tell it that we want to peer with ISP50. So router BGP again 65001. We're not AS30 when we're entering into the router. And also neighbor is 162.16.50.2. Remote AS is 50 and in right. So now in a moment we should see peering between router R3 and ISP50. Okay, so that's good. Now think this is good. Let's see if we defined yeah, we just need to do configuration on ISP 100 I guess at this point. Okay. Okay. So now we have achieved our BGP peering way it should. Let's see if we have any issues with the routing. So if I do show IP route BGP, I'm not receiving any route from R2. Okay. I'll say show IP BGP neighbors 172.16.10.1 advertised routes. I'm sending my loopback address, but we are not receiving any routes. Okay, we're not receiving any routes. So let's see how many BGP routes does R2 have. So if I do show IP route BGP, we only have this. And let's go to R3, show IP route BGP. We only have this route. But if I just do show IP route in general, and I want to exclude connected route. Okay, so I figured what we have to do is we have to start advertising these network. For example, R2's network with the ISP10, R3's network with the ISP50, and R5's ISP network with the ISP100. So these 172 networks that we have to advertise into the BGP. So on R2, I have already done this. Okay, and now let's go to the R3 router. Let's go to actually R5. So show IP route. R5 should start seeing the 203 network. Okay, that's great. Now that we advertise this, this is what only what we did on the R2, and we see this network on R5. Okay, but we don't see 198 network here. So let's fix that. So let's go to the R3. Okay, okay, and it. So now does R2 see the 100 network? Let's see. So I have to show IP route BGP. No, we don't see 100.64 IP. So let's go to the R5 and tell R5 that you want to advertise the network in the BGP. So I'll say router. Okay. So now we should have a full convergence. If I do show, okay. So you see we do have these network 172 networks in the BGP table, and we also know 198.51 network, which is ISP 50, 203 network, which is ISP 10, and how do we know? Why don't we see 100.64 IP? So let's show IP route BGP. Yeah, we see that as well. So now let's say in ISP1, I want to trace route to ISP 100, 100.64.100.0 numeric. So first we go to this network 172.0.1 this link, and then we go to 10.0.0.2 this, and then we go to 10.0.0.6, 10.0.6 to 10, 102, and that's it. We reach to the network. So yeah, even though if I do show IP route BGP, I don't see any 10 networks, but I see the networks. So what's happening is we do have OSP that's taking care of reachability within the autonomous system. So the R2, when R2 gets a packet, it knows how to get to 10.0.0.9 thanks to OSPF, and we're not doing any redistribution between OSPF and BGP. All we did is we connected these neighbors and we advertised these networks into the BGP. So if I go to R2, okay, I do show IP BGP. We do have these networks in the BGP routing table. This is the network connected to ISP 100, and these 16.10 is network that we have. Okay, you see the origin is 000, so router 2 is saying that it's coming from the network command and I'm the originator. And then 10.50, which is this network between R3 and ISP50. And then if you take a look at 203 113 network, this is the network connected to me itself. Oh, sorry, the ISP 100. Yeah, you see we don't have any OSP, but we're still managing to do the routing. Let's go to the ISP50 just for testing. I can ping to the 100.64.100.0, 100% ping rate. If I go to ping ISP10's IP address, which is 203.0.130.10, it's working. And we don't have any OSP, so if I do show IP route, there is no OSPF running. That's pretty much it. I just wanted to highlight how typically ISPs route the traffic and how we will have a confederations and iBGP and eBGP, how they coexist. If you like the video, please hit a like button and consider subscribing to my channel. That helps with the YouTube algorithm. Thank you so much for watching NetTechies. Bye bye.